The F14 XXL is in absolute pieces right now. We're putting this thing back together properly with some Loctite. We are continuing with this project. Thanks guys for tuning in. Let's continue on with the back end and move our way forward. And if you guys are new here, if you're finding this channel for the first time, we build really cool aircraft on this channel. So don't forget to hit that subscribe button. I don't often ask for that, but it's kind of a cool thing. We're almost at 50,000 and this plane is darn cool and worth it. Little summary from last video, we split the fuse, we got the gear out, we got the gear serviced, we got all of our doors serviced in the front end, we got the main gear out, we got the swing wing mechanism out, and everything is Loctited, serviced, and ready to go back in this aircraft. But before we do that, we were servicing all of our gear doors here, and that is now done, as well as our air brake section. So that was the highlights from the first episode. Now, this episode, we are just going to continue working from the back end forward. Now, I don't think we're going to put the wing and main gear in yet, because we're going to continue working from our tail section forward. We've got a lot of little details to deal with. Like our afterburner lights as an example. We've got our working tail hook to set up as well. So there's lots to do in this back end. So let's take a look at the tail hook next. All right, so previous F14, we made the tail hook operational. Obviously this one is a heck of a lot bigger, but we're gonna do the same thing. So what we're gonna do here is we're going to cut an access hatch on the side, and that access hatch needs to be in a position and big enough for us to mount a servo into this area. So that's the first thing we're going to do. I'm just going to take a ruler and a pencil and mark this out. There's really no panel lines or anything good to be able to do that. And I'm probably going to want our servo skewed a little bit towards the front end, so when this tail hook's up like this, our actuating rod has some room to work. So let's get that thing cut open and see what we have to deal with. All right, so we drew out our hatch, and I'm just using the ruler trick here to get my lines nice and straight. So all I do is start the razor saw with a ruler. And then once I'm pretty much through for a fairly large section, I just finish it off with my saw. And there we go. So that is our hatch. Definitely a heck of a lot more room on this guy than the little one, that's for sure. The little one was struggled to fit a servo in there. This one's going to be a lot nicer to get set up. So anyways, this is our hatch. That's perfect. Only goes together one way, so we'll make some little tabs to hold this guy on, but we will work on getting our servo mounted on there and kind of figuring out our system that we're going to use here. So we've got our tail hook underway here. We've got our opening cut, obviously. We've got high sol joining our side to side because we've got double hinges here. So we still want this to hinge up and down, but we want the side to side movement to not be existent. So we've put high sol in there, and I just put some thick CA right around here just to hold it in place. And I'm happy with the alignment of it. It's nice and straight right down the center. So that is great. And but we still have full movement up and down with the tail hook. So while I've got a little bit of high sol mixed up, I'm going to see if I can get my servo mounted in there. I'm pretty sure we're going to be using the MKS HV747 servo, very powerful servo. The goal is to get this mechanically locked in the up position. So in the up position, if our servo arm is pointing this way or towards the front, we can have that locked out as long as we can adjust our linkage properly so the arm is up, linkage is coming like this, and everything's nice and locked out. That would be ideal. So that's the goal. We'll see what happens and how it all works out. All right, our final step this evening is we got our servo plate glued in. These are listed on our website. These are made by RC Custom 3D Printing, and they are absolutely awesome. There's a whole bunch of different mounting styles and everything. These are the flexi mounts, so the actual base there molds to the different shapes. I love them. They're so awesome. So we've got high sol in the center, and then we just stuck them down with some CA on the edges. So this is a little bit sticking up too high. So once this is all fastened down and everything, we'll sand this down. That'll still leave plenty to support the servo. So what I did here was I kind of just averaged it out as far as the position of the servo goes. So what we're going to do is we're going to use a ball joint on this end here, and the ball joint has a ton of movement to it, right? So it's got, I mean, you can see there we're about maybe 40 degrees one direction, so it's got enough to move 40 degrees the other direction. So if we mount that ball on there, when this hook is down, which is kind of in about that position right there, it's going to be sitting sort of like that. And when it's retracted, it's going to be something kind of like that. And again, the mechanical lock we want to have is our ball joint we want to have looped all the way back around, so the servo is not holding this arm up. The only time the servo is under tension is when this thing is down. When it's up, it's basically mechanically locked out, which is going to be perfect. And I think this whole setup here will accomplish that no problem. So we're going to leave that to cure, and we'll come back to this tomorrow. All right, so we've got our servo mounted, we've got our linkage all figured out here, and this is going to work awesome. So used a carbon MKS arm on the servo side, same ball joint on each side. You can see here we did change the arm out. So this was a 2mm threaded piece, and I switched that out to a 3mm so it fits the ball joints better and just a stronger mount. Use the nut to secure it all together, 2 spacers to bring this up enough, and then another bolt, and we can cut that off. But the geometry here I think is going to work perfectly. So the other thing we're using is a Seacraft adjustable arm here, or linkage rod. So that has backwards threads on one side, regular threads on the other side. So when we back it out a certain way, it adjusts both of them, which is great. So we can get this fine adjustment done here in the retracted position, because our servo position with a mechanical lock like this is important. So we want to keep that in the up position, but we want to use our linkage to adjust the actual length. So I'm really happy with that. So this is good. One thing we need to get done here is to put our backing plate in. So we're going to put little plywood pieces on each corner so we have somewhere to screw this down to. Ultimately, the adjustment we can't do right now because we need to get this mounted on the fuselage, and then we can adjust that afterwards. And I do need to screw down my servo arm still. All right, so we got our cover plate basically backing installed now, so this is ready to go. Now we can't do anything with this until we get the model set up in the radio, because we need to have that tail hook set all the way in one direction. So we're just going to set this aside now and not worry about that for now, and we're going to move on to our elevator or Tailoron servos. Big Bad Mama Jammas HBL 388s. These should be fun. And then we're also going to continue working on our back end with our vertical stabs or rudders. So getting into the tail section here, we've got our 2 Tailoron servos, the X8s, and we've got our X6s, the 599 servos. These are the 388s. The 388s are a larger size servo. The pockets in the fuselage are sized for this size of servo as well. These guys fit in, obviously, but there's a lot of room in all directions. So what I'm doing here is I'm laying out all the items so we can take a look at this and get things sorted out as far as what is what. Because there's no manual for this plane, we're going to have to figure it out. Now, I do have a bit of experience, of course, with the smaller F-14, and this is very similar. So I'll take you through this and kind of share with you what I think is going where. So this is our rudder linkages. So I know that because this is the right length, and there's really nothing else that this fits on. These are for the elevator servos, obviously. And the main concern is these carbon pieces. So the rudders both need 1 per mounted to the surface. So based on how this is laid out, it would make sense that we are probably using the double here on the rudder setup, and our ball is going to go in between just like that. And that also makes sense because we've got nice, strong mounting to the actual rudder surface itself. So 2 of those guys will be for the rudder. And then we've got 2 extras plus we've got 4 of these little guys here. So let's take a look at the wing and see what we have to do with this stuff. So essentially on the wing, we've got 2 servos here that are responsible for the leading edge. Now the leading edge has nothing installed from the factory for hinges and stuff. Now there's a slot here right in line with this guy. So we're gonna have to put one of those pieces of carbon right here, and then there's a slot right here, which we'll have to do the same thing. So there'll be 2 servos working on the leading edge. This is our flap servo, and the flap servo works exactly the same way as the smaller ones. So basically this linkage goes in something like this. This piece here mounts to the linkage, and as the servo turns, these linkages turn, which creates the flap movement. Now your flaps are fixed because they'll only move as far as that angle is. So that's the flap stuff. And our slats on the top of the wing, which is up here, that's the aileron function, if you will. There is where are we here? There's a linkage or a hole right here, and there's a small linkage that'll go from the servo to the operation system of the slat servo. So we don't have anything for the slats, we don't have anything for the flaps. We do need some for the leading edge, which brings in these guys right here. So we'll probably end up using these guys for the leading edge. These are some extra ones, which is great to have, and we're using 2 of those guys for our rudder setup. Now I apologize if my lingo is off, or if I called something, if I called the rudder a rudder instead of a vertical stab, but ultimately who cares? We're just explaining the little pieces, how they fit on the individual surfaces. So honestly, I was very worried that these servo arms wouldn't work, but there is just enough room. So we've got a plywood spacer in there. It's about, I think it's 1/4 inch, so it's 5.5 millimeters. That's pushing the servo out in order for this arm to clear the body. We've got the MKS arms, which are about 18 millimeters center to center. These are the Bad Mama Jam arms, the 8 millimeter spline. And we've got the elevator installed, just for fitment here. Now at this point with the elevators, you're always doing a lot of lineup. So if you look at my 2 little marks here, that is the channel, the receiver channel. And we've got our metal thing in there right now, just for spacing. But you can see here, it just clears. So we are pushed up against the fuselage tight, which is how you want it. You want this as tight to the fuselage as you can get it. So I'm very happy that this just fits, which is perfect. It's definitely tight, but it's designed well. It's going to fit beautifully, so that is awesome. Now the only kicker is we want to make sure that the other side fits just like this. Now usually I find there can be some differences in spacing, in elevator spacing. So, the worst thing would be if this elevator is spaced in a bit tighter. That's the only real crappy thing, because we don't have any more extra space with that servo arm, but we'll deal with it as it comes. And we now have our Black Aces program for the jetty. So the positive with that is we can now bind this to our radio system or to our receiver, and then we can also get the tail hook set up as well too, and continue getting the rest of these guys set up. All right, so we've got our tail hook plugged in here. We've got the servo arm just sitting on there, and let's push our tail hook button. There we go. So that is perfect. Awesome. So it's nice that it's mechanically locked because our servo is not going to be buzzing like crazy, and that is awesome. I'm not sure if the up is too much. If the up is too much, we adjust it with our linkage. If the down is too much, then we just adjust that with servo travel. That is cool. Okay, so the horizontal stab surfaces, elevator surfaces are always a little bit tricky to set up. And the reason I say that is because you can't put the servo arm on until the servo is installed, the cover plate's kind of in place, and then you have to get the servo arm installed, bolted down, and then pop the cover plate in place. So it's a little bit of a trick, but what we have to do first here is we've got to bevel the back side of this servo arm, and we've got to bevel it enough so our screw here can recess into that location. Now, this is threaded with 3mm thread, so that's a positive thing, but we've got to bevel that as a first step. All right, tail mock-up is complete. Both sides worked out great. Very happy with the results. And I think everything is going to be just perfect with this, this tail section. So we're going to now pull the horizontal stabs off. We're going to work on getting our cover plates installed and getting everything finalized. Now, the only thing that could change is going to be our neutral. Now, I'm not sure because we don't have any manual, there's no build threads, no nothing on where neutral is going to be. So our 0 on our servo is roughly about there. I don't know if that's going to be correct or not. So in the long run, we may end up pulling these covers back off and adjusting our servo a little bit, but we'll just run with the neutral on the servo for now, and we'll go from there. So, all right, so this would be our standard setup that every Skymaster plane uses. So generally you're putting 3 bearings on there. The only thing that I'm going to change on these guys is because our horizontal stabs are spaced out a little bit more, we're only getting about 2 bearings of contact here with the receiver, and the receiver is wide enough to receive 3 bearings wide. So what I did was install 4 bearings on the receiver here, so now we know we're getting 3 bearings of contact with our receiver portion in the horizontal stab. Just ensures that we get full contact with that receiver. That's, I think, a good little change to make. And I just used Loctite on our nut on the end here because our nylon is not holding. It's the actual nut and the lock nut that's holding everything on. So there you go, small little change. So elevator servos, tail servos are complete. Worked out good, happy with everything. Seems like it's nice and strong, and that is awesome. So we've got our one tail on that side. We're going to pull it off, and this one is good as well. Now, a couple of the final closing remarks here on this elevator servo. As you can see there, we've got just a little bit more gap now. So what I did on both servos, on the leading edge of the servo, so there's 4 servo screws, right? The leading edge, this top servo screw, this bottom one, I put a very thin washer underneath those. So I just undid the screws, slipped it in there, screwed it down, used some CA when I screw those down for the final time. And what that does is that takes that servo and just angles it just a little bit. Now that doesn't change anything because this can move in and out of the pocket as needed. But what it does do is it allows the servo arm to have just a little bit of space. Before it was rubbing on the fuselage, you can see it there. The rubbing's fine, but if we can get rid of it, then it's even better. So now with that spaced out a little bit, we're still good, no contact with the arm, and happy with that. So that is good for the elevator servos. What we're going to do now is we're going to flip this aircraft over. Now the former work back here comes all the way across, so that's no problem to support it back here. On the front, we're going to support it exactly the same way, but it's going to be supported on this top side here instead of the bottom side. So the reason we're flipping it over is we need to get our tail hook mounted. All right, she's flipped upside down. Now I tell you, with the wing mechanism and gear removed, this thing weighs next to nothing. It is incredible how light the back end of this fuselage is. It's nuts. All right, so we've got everything hooked up for our tail hook. So the linkage is all hooked up, servo arms all hooked up. Now, when you look at the scale pictures, basically the end of the arresting hook comes almost flush with the tail section there. And there's kind of a predetermined set of angles that kind of line up with the front part of the arresting hook pod. So that's how we're going to get everything lined up. So just working on that. All right, so we've got our area sanded down with the Dremel. Same thing on our tail hook assembly here. And we've put high sol on our fuselage portion. If you look closely, you can see the very light colored outline of the pencil mark that I wiped off. So that tells us exactly where we need to put it. And we're going to just kind of spot glue it in place with some CA. All right, so we've prepped our cover here for the tail hook, and the tail hook is all installed. So we're going to make a little bit of an adjustment to the linkage to make sure that this is up as high as it can go. And then we are ready to run our servo lead from this point here forward. Now I made a hole in the fuselage and the hook thing, so it's right in there, and we will run a line all the way to the front. Now here's our power box extension that we're putting to the front. Now I don't know exactly the position of our central box 400 at this point, so I just made up the extension with this on the one side where the servo is going to plug in. This side is just marked, and we're pretty much going to do that for all of our servo leads from the back end. And I made those servo leads long enough to come right to the front of the intakes, which takes care of any equipment that we may place in the front end of this airplane. So I don't know if the central box is going to be here, back here, forward, but that gives us options at least. So we got our extension finalized here for our back end. So we've covered this in really skinny snakeskin. I love this stuff. I just ordered it, and I ordered a lot. So we've got this stuff to use, which is great, and it just fits the power box wire in there. So we'll run this now from our tail section. All right, we are moving on to our vertical stabs / rudders, but before we do that, we are going to check our tanks. Now these have had a couple days to cure up, so we're going to get the insides cleaned up. We're going to get our clunk lines done up, and then we are going to leak check or pressurize these tanks to confirm that they are in fact holding air. So let's get the tanks done up next. All right, so we got both of our clunk lines done up here. Now these are matching lengths and everything, but because we've got two separate fuel systems on this aircraft, that doesn't really matter, but we kept it detailed and kept them the same. We're using Virilison clunk line or Virilison fuel tubing on these clunks. Now this comes in black or this clear, and the nice thing about it is it never hardens in fuel. We've got a 5.5 millimeter brass tube, so oversized tube, and of course the DreamWorks clunk. And the point of doing this is so the clunk doesn't fold back on itself. So this keeps it in the right position, and we've tested them and fit them, and they're all good. Tanks have been rinsed out with isopropyl alcohol, so those are all done. And what we're going to do now is put a drop or two of silicone lubricant on the O-ring and get these guys fastened in. All right, so this is how we pressurize our tanks. So we've got one end closed off with our Tygon tubing. We've got some other tubing installed on the bung fitting. If you're going to put it on the bung fitting and you've put alcohol in here, just be careful because there's usually a little bit of residual. So if you blow on this and you let go and the air comes back, there's probably some alcohol that's going to come back. So just be aware of that. And all we do with this is we just pressurize it with our mouth. So get the forceps ready. And there we go. So we can see the tank is under pressure. It's got lots of, you could actually see it rise up. So now we'll just leave these to be and leave them for a couple hours. We can leave them overnight, ideally, if you have time for that. But, you know, if you leave them for 4 or 5 hours and then you pull the forceps off and there's air that comes out, you're good. We've set our tanks aside. We're going to leave those guys be. And now we're moving on to our rudders. Now, they are symmetrical. So the bump out here is the same on both of them. So one, the bump out is on the inside, one, the bump out's on the other side. I don't know if that is correct scale-wise, but that is how they've designed it. So a little bit of a different setup from the inside to the outside. But what that does is that makes our setup of both of our rudder surfaces the same. Now, a couple important things when you're taking a look at this. So our rudder servo mount sits at an angle like this, which is perfect because that is perpendicular to the hinge point, which is exactly what we want to see. And I've just done up our linkages here. And the point of that is I'm going to get these linkages CA'd in place so they're stuck in the right position, and our ball joint is squished in between them because that is exactly what we want. So what this is going to look like sort of is we are going to have these carbon guys mounted in the base of the rudder surface. Now there's a big piece of wood in here. I believe it's probably balsa, so we'll be soaking that in thin CA. So I'll show you guys the steps. I'm just giving you the basic overview of what happens here. So that is what our linkage is going to look like. So we got a ball joint on this side, big heavy duty linkage arm here, which is nice. And then we've got the good old golden clevis, which is the absolute strongest of all of our options that we have. About 2.5 years ago, something like that, there's actually 2 videos that we did here on the channel, and we tested the various ball joints and clevises and the things that we have available to us as RC modelers to torture testing, and the clevis like outperformed everything else by a factor of 2. So I think like the ball joints and stuff like that, they would fail about 80 pounds of weight. They would just stretch and fail. The clevises, I believe from memory, were like 180 pounds or 175 pounds they would support before the pin finally snapped. So the golden clevis is definitely the best option for strength. So I'm going to wick a little bit of CA into these guys, and then we'll pull these off, and we will look at how we're going to get these mounted on the rudder. All right, so I'm going to try and show you exactly what we're doing here. So basically what we want to do is we want to make sure that when this is all the way in this direction, we have enough clearance for our ball joint and everything. So like that. And then when I fold this over in the other direction, we don't have any interference on our wing skin there. So what I've done is I've held this in place, bottomed this out on the actual plate that's right here, and drawn a line there. You can see we've got 2 different sets of lines because I was just adjusting it, but this is basically the position that we're going to have that in. And then I went in here and put a pencil mark there, and that pencil mark lines up with our servo mount that comes in this direction, right like this. So that tells me that when we install this in the actual rudder, we're just going to carve out a space in between the black mark and our skin here. We're going to try and save the skin of the actual bottom part of the surface, and this is just going to tuck in there nicely like that. So that is how we got everything lined up, and I believe that should work beautifully. All right, so you can see here our cutout. So the intention is to keep the skin here and just have this guy slip in, but this kind of gives us some dimensions to work with, and I just drew these other lines out just as a rough guess on what it'll take for this to slip in. So I'm going to take my Dremel now, and we're going to carve out this area. So I'm going to make it a little bit excessive, trying to keep with the horizontal here, but it's okay if we go too big because we're going to fill that area with high sol. And once we've got this cut open, if this is balsa, we're going to treat that balsa with thin CA as well too. All right, so this will give you an idea of what we are looking at here. So this is pretty much it. We're just making sure that our carbon arms here are in fact perpendicular to the hinge line. That's why I've got the pin in there, just to give a visual. And that's pretty much it. So what I'm going to do is I think I'm going to drill this guy out a little bit. So we're going to drill it, put a bunch of aggressive texture on the carbon arm, and then we are going to get this installed, probably just spot glue it first, so we can put this back in the surface, confirm we're happy with the position of everything, then we'll just pop that free, wick some thin CA on the balsa that's in there, and then we will go to town with our high sol and get that stuck in place. All right, so we've got everything just mocked up here. The arm is just CA'd in place with 1 drop of CA, and this allows us to check the clearance on everything, and our clearance looks beautiful. That's exactly what we're looking for. We can mechanically push this surface all the way to the right, and we are not quite bottomed out yet on the plate back here in the vertical stab. So that is wonderful. And then our line up here looks like it's perfectly in line with where we need it to be, so it's not going to interfere with the servo mounting plate. All right, so we got both of our rudders, mounting points there glued in place, positioned very well. It's very tight to the exterior skin there and should be perfect. So we got lots of high sol in here, and there is a little open cavity in this back area. So what I do is I take a piece of sponge and just shove it back there to create a stopping point, and put some CA on it as well too. So when I'm putting high sol in there, there's actually a definitive stop point as well. So those are done. We're just going to leave those be and let them do their curing thing until tomorrow. Okay, so the tail cones come in two pieces. There's kind of that inner liner piece. So we laid the tail cones down like this, set those inner pieces in, spot glued them with CA in 4 spots, and then I went in with some high sol and just put a really thin bead all the way around the perimeter. So those guys are glued in, and we're just letting those pieces cure. This last step here is one of those things that you could probably get away with not doing, but the disadvantage of not doing this is all of the force is really relying on your screws. So when you put these receiver pieces in, there is just a fraction of play in the wood, like not much at all, really close to nothing. So what you do in this case is we put some thin lubricant on the receiver portion here. So I'm just going to take some shock oil, some silicone oil, put it all around this part right there. And then what we're going to do is we're going to take high sol on the actual piece in the fuselage and just put a thin bead around this base piece right here. And the point of that is when you install this and it's curing, that just creates a gap filler all around this perimeter. So when this is operating and that bearing system is inside here and it's putting force up and down, all that force isn't on the screws, it's on the actual opening itself. So it's a good way to make sure everything gets transferred to the structure in the horizontal stab. So what I'll do here is just take some shock oil, silicone oil, put it on a bag, and then we will take a Q-tip like this, cotton swab if you will, and just make sure we get that all over the receiver portion. And the point of this is just to make sure that later on, if you get a whole bunch of flights on this plane and you need to replace these things because maybe they wear out, you're able to get these guys out and they're not permanently glued in place. So what we do is we take our trusty bent screwdriver and some high sol and just put a really thin bead all around here. And then when we set this guy in place, now I've already put some thin CA in the screw holes, so that's done. And when we set that in place, we're all good. Now we'll get this screwed down, and that will create a nice solid pocket for this piece to ride in. All right, it's been a full 24 hours. I can see that our tanks are still pressurized, so when I release this, it releases pressure. Tanks are good to go. All right, we're putting some heat shield on our tail cones here. Number 1 for heat protection. Number 2 for reflectivity of our afterburner lights. So those will bounce around in here and absolutely glow out the tail section. So we will put 2 more coats on of the heat shield as that cures. And then we're putting some snakeskin on our surfaces, all coming from the tail section. So pulled our afterburner lights out of the package here, and I just put some shoe goop. This is goop, the marine variety. Just put that on the wires here where they connect to the board. Now the reason I do that is that provides a little bit of strain relief for the wires, and I'm also getting this kind of planned out as far as where we're going to put it. So obviously those afterburner lights mount on our cones, and the wire is going to reach to about this location here. So we're probably going to be putting our controller for the afterburner lights back here, which there is nothing in this area, so it's a great spot for it. We may end up putting our turbine controllers back here as well too. We may put them more forward, probably more like in this section right there. We'll kind of see how that all works out. This is just me talking out loud, but it's going to make sense to put our afterburner light there. and then our power to the afterburner light goes forward to the central box. Okay, so we got our elevator lines hooked up here. I got those hooked up, and I'm kind of thinking about the afterburner lights and how we're going to run everything. And next thing I'm going to do is get the vertical stabs or rudders complete. So the rudder wiring is going to be going through the skin in this area, go towards the center, and then forward in the aircraft. All right, so our rudders are laid out. The next big step here, we got this glued in last night, so those are nice and cured now on the hinge points. And we're gonna pull our actual surface off. We need to get a hole through this wall right here, which is pretty easy because that's just foam or Arex material. And then the next big challenge is to get our servo in there and figure out how long of a servo arm we can fit on this, this setup. Obviously we want to be long enough where we get decent control, but we can't go too long or we're going to hit the side skin of the surface itself. So just did a little mock-up here with the rudder setup. Try and show you guys. So if we get the linkage installed, one of the things is on this side of the linkage we got to keep it as tight as possible to match up with our horn. But there is some structure in here that we need to be careful of because we can't just start grinding stuff. So when this arm is installed in the right spot, it's going to sit really close to the center line of the servo. So what I'm going to do is I'm going to sand a little bit of our cutout here towards this skin so we can slide that servo towards the skin and still use a reasonable servo arm. So just to give you some reference point here, right now, this is pretty much the location of our output on the servo arm, which isn't going to work so well in order to keep anything from rubbing. So we're going to have to extend that just a little bit more. So we need to get a couple millimeters more movement out of that pocket. So the rudders are taking a little bit of extra effort here just to figure out the linkages and everything. Now we can't use a clevis on the servo side because there's a bit of an angle here. So where this naturally mounts, it sits on an angle like that. And so yeah, we have to use a ball joint on both ends, which is totally fine. We just need to get everything set up. So here's our arm setup, carbon arm, the MKS arm. That's got a hole already in there as close as possible, which is exactly where we need it. And this should work out good. So we are getting this now, the arm installed on here, and then we'll get the servo run, or the servo and linkage and everything run into the vertical stab. All right, so our first rudder is all set up here, and this setup worked out really nice. So previously, because this program came from our last F-14, our rudder, just the way everything worked out, it was so tight in there, we actually had our travel down to 25%, and the F-14s, they don't need a lot of rudder travel, so the previous one, I mean, it only had very minor amount of rudder travel anyways. So, but what we've been able to do on this one is max that out or put it up to 100%. We can actually go further, but we're already getting more rudder travel than we actually need. Everything is very tight. I'm just going to unplug that there. Everything is very tight with the linkage setup, so there you go. Nice ball joint on that side, the carbon arm. The actual surface here, zero movement on it. So rock solid. It's a great system and should work out really well on this plane. So we're going to snip that excess material off the arm, and we will paint this white eventually as well too. But that first one is all figured out, which is a massive amount of work. Now the other one should hopefully go a little bit quicker. So second rudder vertical stab is complete. This one we've got two light wires and then our servo wire, so that's done exactly the same and everything worked out perfect with it. And in preparation back here to run our wires, we have put some through fittings. These are our 6mm Festo through fittings, which are perfect for this scenario because our light wire ends fit through there perfectly, and then we don't have the servo end on our rudder lead yet. So that's where our wires are going to come out. Now these vertical stabs are staying on this aircraft. They're not coming on and off when the owner's moving it around. So they will be removable obviously, but they don't need to be removable easily. So what we're going to do now is we are going to secure our bolts holding the rear bracket together. So those guys right there, we're just going to check those and make sure they're nice and tight. And then we'll be probably running our wires here next. And vertical stabs are mounted. Fairly straightforward. You basically have two mounting points. So the first one is a 3mm Allen bolt that goes into a blind nut that is secured in the fuselage. So obviously we've put Loctite on those guys. Secured this down first, and then with pressure on the stab, we secured the back end. Now the back end is, you use a 3mm Allen key, so it's a 4mm bolt, and you get through it there. And as I showed previously, the clamp is right there. So nice, solid, strong system. And our rudders themselves, like zero play. They are extremely solid. So that is perfect. That's exactly what we want to see. We want to see a nice solid surface. No risk of flutter there, that's for sure. So big step accomplished with those guys. If you guys are looking for something a little bit extra, definitely encourage you to check out channel membership. Channel membership is early access to our videos here at the Lighter Side of RC. So with this F14 as an example, our channel members, our current channel members, they've been able to see these videos about 2 weeks before they're actually coming out on YouTube. So, all right, and that's gonna wrap up video number 2 in the series of the Skymaster 1/5 scale XXL F-14. This aircraft is such a beautiful aircraft. I'm impressed so far. It's been the normal challenges that we find with any Skymaster aircraft. The construction, although very light, is strong where it needs to be, and I think we're gonna hit the weight limit of this aircraft. So yeah, we made some good progress in this video. The stabs, vertical and horizontal, are huge progress markers to get completed. Next video, we're just going to continue moving forward in the aircraft. We're going to get our tail section all completed. We're going to reinstall our gear and our swing wing system and continue moving forward and possibly move into the wings. So we'll see how things go. Thanks guys so much for tuning into the videos. If you have any questions or comments, list them down below. You can also shoot me an email, thelightersideofrc@gmail.com. Thanks for watching, and we'll see you in the next video.